Are you ready?
Welcome to yet another episode of HVACR Versed. I'm your host, Kevin Stiles. As usual, it doesn't change. So, I had recorded this video over the weekend. It was actually technically Labor Day Monday. And when I was uploading it, apparently it was glitching out. And I tried uploading it again, and it still glitched out. And I don't know what the issue is. I don't know if there was a compression failure with the video or what. So, I'm just going to re-record it. And I want to talk about training and continuing education and the state of what our industry currently is in with technicians. So I've seen a trend over the past, 10 years that everyone assumes that they come into this trade and they're going to know it like that. And they don't need to continue their education, or people assume that it's their employer that's responsible for their community, their education. They don't want to train and expand on their own, or they don't want to go to any kind of trade school and become better. They just assume that they can jump in, be an apprentice 1 year or 2 years, and they know everything. It's not the case. It really isn't. But I'm not saying trade school solves it all. I'm seeing a really bad trend with some of these trade schools where you're spending $20,000 on some of these trade schools. And I taught at one of them. And it's just horrible that they're not giving the actual needed steps to become better and actually understand. They're just spoon feeding information, not challenging, not educating. And for $20,000, you can go get a BS degree. I'm not saying I don't know how much a degree is anymore, but when I started doing this, I was younger, working for my grandfather, decided to go to trade school, and there was things that I thought I knew, but I really didn't. And then I got a lot of other hands-on experience for things I didn't know from trade school that I would eventually figure it out, but wouldn't have been fast. And then I moved on to get a degree in engineering, and I'm not saying that makes me the best in the world, but that's kind of a path of how I took. And I've been doing this for about 23 years now. And what I'm seeing today is either employers are just throwing guys to the wolves that are straight out of trade school, not giving them any kind of help. They assume that since you went to school, you should know everything, you should have the basics. But I'm learning that trade school is not teaching the basics. They're just spoon feeding a book. And I have a technician. I want to see his book from when he just graduated from one of the trade schools for air conditioning and refrigeration. So I feel like some of it's still the same stuff that I was getting fed. And when I went to trade school for air conditioning and electrical and solar and all that stuff, a lot of that stuff doesn't exist anymore. Like, we didn't dive too deep into airflow because back in the day, airflow wasn't a huge deal. Like, your fan's running, you're good. Now we look at static pressure. And when my grandfather was doing this, learning from him, I never once checked static pressure on a system. And I learned how to charge a system off of a dial-a-charge. Just saying. But it's not your grandpa's air conditioning anymore today. Now it's getting more technical and more scientific. And I'm actually enjoying the trades more now that we're getting more technical and more scientific. In about 15 years, guys, these contactors and capacitors, they're going to be out the window. They're going to go to this inverter equipment, and you have to have a technical mind to do this. But I'm curious, are employers spending the time to train people? And how are you training people? Because I have a hard time with the amount of technicians that I have to give the proper training, in my opinion. And by that, I mean, I may have these 5 technicians over here who need to go deep dive into something that's more advanced and takes a little bit of a higher information of knowledge of a background to understand that, versus these 5 technicians, they might kind of get it, and then these 5 technicians, they totally, it goes right over the head. But it's hard to find items to train people, because I'll teach something like troubleshooting low voltage shorts. I'll look in the background during our weekly trainings, and I'll see guys that are just like rolling their eyes and falling asleep, not because they don't want to pay attention. It's because there's nothing they're going to learn from it. It's just like a repetitive thing, or understanding charging methods and all that stuff. It's too fresh and like too young of an experience for them to sit there and go through over and over and over and over again. But then there's guys that are in the room that have only been doing this for a couple years or for 5 years, and they need that stuff. They need that better, deeper understanding of how an ECM motor works, how airflow works. Like, not like in the full sense of like full on airflow dynamics, but like the basics of airflow. And I have a hard time of trying to find a balance of where everyone can be trained. But then I look and I can see in some of the jobs that some of the guys just don't understand. And a lot of technicians, I find, they get lucky, like through accidents. Oh, you diagnose the thermostat wire being bad, and then you were right by an accident because you diagnosed the wrong side of the thermostat wire. You diagnosed the thermostat side going to the air handler, and it was actually the thermostat wire going to the condenser. You just got lucky on telling the customer guess, but then when you go out there and you start doing the work and you realize it's not the thermostat wire, and then someone else goes out and goes, yeah, it is, but it's this part, not this part. And a lot of guys get lucky, or you get what I find today is a lot of selling technicians, where it's not running, sell them a new unit. If it's over 10 years old, sell them a new unit. If it's over $1,500 in repairs, sell them a new unit. Sell them a new unit. And they don't understand how to actually fix something. We've gotten away from the idea of how to actually fix something. And I find more and more and more as time goes on that guys are starting to go like, oh, I need to put that OEM motor in. I need to put this OEM blower motor in. And then that blower motor is, I don't know, $600-700, and you can go get a Gentech Evergreen motor that's a replacement for that. It requires a couple extra steps, and it's essentially the same motor. It's just not programmed, and it's not OEM. But because it requires a couple extra steps, and they don't understand how that motor actually works, it scares them, and they don't want to do that. Same thing with contactors. I've heard like so many times, oh, my contactor's the wrong contactor. Why? Well, because I don't have these screw heads and it's got these like lug things. It's a contactor. I could see if it was like a 120 volt coil and you need a 24 volt coil, but it's just a contactor. It just looks different. Or they had a 3-wire condenser fan motor, and now they have this aftermarket motor that's a 4-wire, and they're like, well, what do I do with that? Or they don't understand that brown-white wire on that aftermarket motor is actually the same as L2 on the motor. It's common. You don't need it. It's a 3-wire motor. They just threw that brown-white in there to help you out in case you didn't have enough wire to reach the capacitor, which makes no sense to me. But that's kind of what I'm seeing, and it's becoming more and more and more of a trend, and more people aren't wanting to come in this trade. One, because they think that either A, straight out of school, they make a ton of money. That's not the case, because you really don't know anything. You just barely got your feet wet. Or they come in and they're doing like maintenance and apprenticeships, and then they do it for a year and they go, well, I can change a compressor, I can change a fan motor, I can do this, I can do that, I can replace a TXV, I can braze. But the problem is you're not just a parts changer. You're supposed to be a technician. You're supposed to be able to troubleshoot. Now, how did you get to that point? Did someone else diagnose that for you, and then you're going out putting that compressor in? Because at that point in time, you're just a parts changer, and we're just teaching order of operations. We're teaching set task. Task training is what it should be called. We're teaching tasks. Fan motor's bad. Do this, 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 this. Well, a lot of guys don't know why the fan motor's bad. I've seen blower motors and the boards be replaced for the wrong reason. Both. The same unit. Blower motor got replaced. The board got replaced. Well, why did you replace the blower motor? Because it wasn't running. Why did you replace the board? Because the blower motor wasn't running. Was the blower motor not getting a signal on these ECM motors? No, it wasn't getting 24 volts. And then you look at the motor and you go, oh man, that's wildly wrong on what you just did. The motor was probably fine. The motor or the board was probably fine. You were looking for the wrong thing, because that motor's not looking for 24 volts. It's looking for a DC signal. So I see this too often now. Or we have a capacitor that looks a little bit different, and I don't know how to wire this up because it looks different. Well, why? It's just a capacitor at the end of the day. Or I was replacing PSC motors with these evergreen drop-in ECM motors. It was so confusing to understand why there's no capacitor, why you have to mount the module in the airflow, why you have to do all this different stuff, because nobody understands the actual technical side of it. We're just task trained at this point in time, and it's become a problem. Or we're misdiagnosing thermostats that probably weren't bad, and we're just doing it the wrong way. So these are kind of like what I'm seeing and the trends that are currently happening, in my personal opinion. The other thing I'm seeing is guys just want to upsell, and we don't know what we're actually selling the components for. And they put the right thing in, but for what reason? They don't know why they're actually putting that in. Why are you putting that hard start in? Why is this fan motor failing? Why is the system low on charge? Is the system low on charge? Why do you think it's low on charge? Because you hook up your gauges and you go, man, my suction pressure looks low. And they go, my subcooling's a little low. It could be a fine. But they just go, let's just smash some gas in. And they smash some gas in, and the problem that really was going on gets resolved, not through them, but by a customer on accident, because they didn't pay attention and see that filter was a little dirty. And customer replaces that filter. Now you have that airflow, and guess what? That unit's overcharged. It's just stuff like that. Is we're not learning the technical, the whys. No one wants to ask why anymore. Everybody just wants to Google search, and which I see the problem is Google's there. I used to have to carry around training manuals, ice machine manuals, all this stuff. Now I don't even do that. Like, a lot of my manuals are sitting upstairs in my loft on my bookshelf, or I have manuals sitting back here that I don't need to use because everything's digital now. I can literally Google search Hoshisaki KML 500, and it'll tell me all the specs about that unit. It'll give me breakdowns, tell me how to clean it. It'll do everything. It has troubleshooting guides on there. I can do X, Y, and Z without ever pulling out a manual. I can find that. I mean, there's so many apps now, Blue On, stuff like that, but guys don't want to do that. They want to be just told. Everybody just wants to be told what's the problem, what to do. And 9 times out of 10, whenever I get a question about, like, oh, this is my problem and I don't know what's going on, I've checked this, and this, I'll ask a couple questions, and I'll ask, well, what's your static pressure on the system? Not static refrigerant pressure, because I found out apparently a trade school out here is teaching static refrigerant pressure to see if you have air and non-condensables. That's goofy in my personal opinion. But I'll ask, what's your static pressure? And they'll be like, I don't know. And I go, well, find out and call me back. I never get a phone call back, and then I'll call later on, like, what was going on? What'd you find? Oh, I had 0.89 inches of static total, and it's like, you wonder why your unit was freezing up. Or, oh, I don't know why this unit's freezing up. I don't know why my static's high. But they don't want to do some simple thinking, and you ask, well, is it a zone system? Yeah. Is there a bypass on there? Is a zone stuck closed? Nope, every zone's calling. That doesn't mean every zone is open. That doesn't mean that. So it's kind of the thing, and I've been, like, since December, I've been looking into different ways of how I can train people and give individualized training based upon what they actually need to succeed and become better. And I came across a company, Interplay Skill Mill, and I, I I've been going back and forth with this since December, and I finally pulled the trigger on it like a couple weeks ago. Been testing it out. I'm rolling it out to all the technicians, all the plumbers, all the installers starting next week, and it sets individualized training based upon their needs. They'll have an assessment test, and they can take that assessment test and see where they need to go from there. And it's not just a verb, because some guys don't learn from verbal exercise. Some guys don't learn from reading. Some guys don't learn from hands on. Some guys need all three. And I've been playing around with it. And what's nice about it is it's verbal, written, and hands on virtually. It's virtual training. And you can monitor progress and see, like, hey, they're getting stuck on this electrical portion way too much. And you can spend a little bit of time with them in the field and help them out a little bit better. And I'm going to be honest, for some people out there, if you don't grasp it after a certain amount of time, this trade is not for you. You have to be able to grasp onto this stuff. You have to be able to learn. And who ultimately is in charge of your education or you furthering yourself in your career? And I say career because this is a career. This isn't a job. Now, I know we may go to a company for a job, but if you chose this industry, this is a career. This is a life choice. And there's some tough life lessons in this industry. And I've learned through, I'm not trying to brag or anything like that, but I can pick up a book and I can read about something. I learned about chillers without even touching a chiller. I learned all the basics and all the properties of chiller systems without ever once touching a chiller, because I'm able to read and comprehend that. Now, did it make it even more like clicks and ahas when I started doing it and working on it? Absolutely. Did it make 100% sense from a book? No. But I learned through that method. I still am learning to today after 23 years of doing this. I'm still learning things. These residential systems, and it's not the basics I'm learning, it's the little quirks and the little small things of each piece of equipment that I'm learning every single day. I'm watching videos. I'm watching Brian Orr from HVAC School. I'm watching Jim Bergman. I'm following stuff from Measure Quick. I'm constantly learning. I'm constantly doing this. I remember I wanted to learn ammonia refrigeration. Nobody was going to pay me to learn ammonia refrigeration. So I paid for myself to go to Garden City, Kansas, go through the school, and you know what? It cost me something. Not only did it cost me money, but it cost me time. I lost money because of it, because I wasn't working. And I took everything from that and I absorbed it all because it cost me something. Whether it's blood, sweat, tears, money, time, those are some of the biggest learning experts. The touching, the feeling, the smells, that stuff, that the painful stuff that hurts, you learn the most. I personally feel now, if you're just given something, it's the old saying of, give a man a fish, he eats for a day. Teach a man to fish, he eats for a lifetime. If you're just given training and there's no exchange in it, like no painful exchange, nothing, it didn't cost you anything, you're not really paying attention to it too much. I'm not saying this is everybody, but this is what I see for the vast majority. I'll sign guys up for certain courses for the Electric League of Arizona that I teach for Heat Pump Council, and they won't even show up. And I still have to pay for that seat. So I started telling guys, you don't show up, I make you pay for it. It comes out of your pocket. Now, if you show up, I'll pay for it. I'll pay for that class. Now, that's when guys started actually showing up and started doing things. The train tech programs, we pay for those, but it's still only a certain amount of people can go to those courses. Now, how do you individualize that training? And that's what I'm having this whole video about is, I think I found something, and I'm not saying like nobody's heard of this, but I think I found something that can kind of help. And let me move over to that screen. So it's called, it's from Interplay Learning, and it's the program software is called Skill Mill. Guys, this also is giving NATE credit hours. So you can add your NATE ID. I haven't done this yet. I've just been kind of messing around with it. And like I said, I've already recorded this video kind of once already. And you can add your NATE ID in here, and it gives you NATE continuing education hours. And that honors the NATE credits. So in here, you have different things. I was using one of these to do on how to use a multimeter, because I don't know how many times I've had guys that don't understand what a multimeter, like what each symbol in a multimeter means, or what the symbol of a capacitor is on a wiring diagram, or how to read a wiring diagram. And this goes through all of that, and it can figure that out off of an assessment test and see where they need to be. So there's catalogs, and it's got HVAC, commercial HVAC, solar, plumbing, electrical, like maintenance facilities, safety programs, hospitality for hotels. It's got professional development for like learning selling skills or how to talk to customers and stuff. Appliance repair. It's got all this stuff in it that you can choose from. And then you can monitor each tech's progress. So right here, this is just my thing that I've been messing around with. And you can see everyone's, it's not what I wanted. Go to my team. So you can, I have this many seats available. The one seat used is me for an administrative use. I haven't signed everybody up yet. I'm working on getting all their emails put in. But you have 44 seats available. Guys, this is not cheap. This is going to cost the company money. So what I've told guys is, hey, I'm paying for this. I'm going to take care of this. I will monitor it. This will go towards your raises, etc., and your personal development. This is on your downtime. You're at home, spend 15, 20 minutes doing one of the sections of the course. And some of these courses don't take that long, and you can move through it. So like this one I was going through, and I'll kind of show you guys. Let me turn the audio on for the computer. So this is just measuring capacity.
Now in this short video, I'm going to show you how to measure capacitance. Now not all digital multimeters are going to provide this function, but the one I'm using here in fact does. And I'm using some motor capacitors for my example here, but any capacitor would apply to this procedure. Now to start with, we need to plug the meter leads into the correct.
So this will be really good also for like people that are apprentices. You can help further them without having to spend hours and hours and hours and hours and hours in shop, paying them time and teach them at the same time. And this is already pre-built stuff.
Inputs on the multimeter. So I'm going to start by plugging the red lead into this input jack here, because we do have the capacitance symbol here. And then the black lead goes into the common input on the meter. Now, we need to turn the rotary dial to the capacitance function or mode. And it just uses a simple little symbol of a capacitor here. I'm going to turn the light.
I can tell you right now, I know several technicians out there from different companies that look at a wiring diagram and do not understand that symbol means capacitor. And they'll look at they'll switch to that on their meter all the time, and they don't realize on the wiring diagram that means capacitor.
Light on, so that we can see the display a little bit.
Let's just fast forward a
Play
little
on
bit.
the meter, we can see that we have 38.5 microfarads. Now this capacitor is rated for 40 microfarads, so that's okay. With run capacitors, you want to be within plus or minus 10% of the rating on the capacitor. So again, it's that simple. Now the start capacitor is...
Now that's one thing I did see earlier. Go off of what the capacitor says. Some capacitors say plus or minus 6%. Some capacitors say plus or minus 10%.
Going to have a higher microfarad value. So when I place it across these terminals, we should get a substantially higher reading here on the meter. And we'll just give it a second to calculate. And we see that we have about 116 microfarads on the start capacitor. Now, a bad capacitor would produce an unusually low reading or possibly no reading at all, 0 on the display. One more
Let's just fast forward.
Terminal, and we can see.
Let's go to the simulation. This is kind of where it helps out a little bit. So there's VR function where you can have virtual reality goggles. If my technicians start to show that they're really utilizing this, I will purchase those and I'll try them out. And you can just do it on the desktop version or the mobile app version. So you get this simulation training. It's creating all the simulation points and stuff. This does take a little bit of time when it's doing this. So it tells you up here, it says, use the multimeter to measure the capacitance of the 3 capacitors. Hit OK. And then it says, set the multimeter dial to the resistance setting. You can see the capacitance is the secondary menu option. So it's making you set this dial. So you go to there, and then you hit OK. You're on there, and hit OK. Then it says plug the leads into the input jacks. The black lead plug, and it says plug the black lead into the black common section. And then it says take the red lead and put it into here. So then you go OK. Now it's telling you press the yellow button to change it to capacitance, because that's the secondary menu. Because if you look here, the capacitor is yellow, so you got to hit the yellow button to change it to capacitance. Sometimes it gets a little goofy. See if I move around, if it'll change. Oh, because I'm not on capacitance. That's why it's not letting me do it. All right, now we're on capacitance. See? It's telling you you're doing it wrong. And you got to figure it out. I just had to figure it out. I wasn't paying attention, and I didn't see that the meter moved to the different scale reading. So now it's saying, even though a capacitor has no power, it can still hold a charge. Always discharge the capacitor and then disconnect it before testing capacitance. This has already been done for you in this simulation. Okay. Now it's telling me, measure the capacitance on the start capacitor. Place the probe across terminals on top of the start capacitor. Does the multimeter read 200 microfarads? So let's take our red lead. Put it on there. Take our black lead, put it on there. Does it read 200 microfarads? Sure, we hit yes. Let me move this down here so you guys can see. Since the multimeter measurement matches the value, 200 microfarads printed on the side of the capacitor, it means the capacitor is good. Awesome. Okay. So now, next, test the run capacitor. Place probes across the terminal on the top of the run capacitor. Does the multimeter read 20 microfarads? Let's put the red on the red and put the black over here. And does it read 20 microfarads? Nope. The value on the printed printed on the side of the run capacitor is 20 microfarads. Is this run capacitor good or bad? It's bad. So let's get rid of it. That's what it says. Now it's telling you let's check the dual run capacitor. Does it read 25 microfarads on Herm? Yes. Test the common to fan by placing one of the probes on there. So now we need to put the probe onto here. Does it read 5 microfarads? Yes. It is a good capacitor. Finish. Congratulations. You've completed that part of the course. And it'll ask sometimes in here, did the capacitance help you feel more prepared to do this task in the field? Yes. Thank you for your response. I will, sometimes you do that, and then it'll give you a knowledge check, and it'll ask questions. What should always be done prior to measuring the microfarad value of a capacitor? All of the above, because you want to discharge capacitor, turn off the power, isolate, disconnect, all that stuff. Submit the answer. Cool. Got it right. Quiz complete. Done. So that's just one of the simulations. This one was multimeter overview. This one was RMS meters. This one was measuring voltage. This one was nice because I'm just going to go through the simulation. I already launched it. Got to move it over. So it's going to load it all up, get it all ready. And by the time, there we go, we hit start. And it says, use the multimeter to measure the AC voltage on the open tabletop switch. Okay. So it's telling you to select the AC voltage. So you go there. Now, if I select anything else and I hit OK, it's already going to say it because I already went to AC voltage once. But I want to kind of mess this up here. I plug the leads into the common jack and then onto the red leads into the voltage input jack. Now I want to change. It's not going to let me change the meter. There we go. So measure the voltage, place the leads on the black probe. Place the probes on the screws at the base of the light bulb. Does the multimeter read 120 volts? Now, you put it on the wrong setting. It's not going to let you do anything. So we got to select voltage to let it do it. Now, it's letting us do it. So it's forcing you to do the correct thing and see where you messed up. So, yes, it reads 120 volts. Awesome. Place probes on the screws of the light switch. And does the multimeter read 0 volts? Yes, because the switch is closed. There's no potential for voltage. The voltmeter measures the difference between electrical potential between the 2 points. There's 120 volts going to the switch, 120 volts going out. So 120 minus 120 equals 0 volts because you have no potential there. The potential is gone. You're pushing power through. Now it's telling you to open the switch and then check. And this saves you from having to build all these trainers in your shop and stuff. So we flip the switch off. Now measure the probes at the light. Is it telling us to measure the light bulb? Yeah, so we have to move this around. I wonder if I can move this meter. So do that. This is only sometimes, like, I don't like how this works sometimes. There we go, I was able to move the meter. All right. Now I should be able to see what I'm doing. There we go. Place that probe there. Let's back out. Let's move our things here. Put the probe on there. Oh, we got to go back to the voltage. Once again, it's not letting us do it because we're not in the correct setting. So now it's going to let me put the probe on there. Do we have 120 volts? No, we do not. So now it's telling us measure the voltage at the switch again. And at this point in time, we should have 120 volts at the switch because there's potential. Measure the voltage, place the probes on the light switch terminals. Does the multimeter read 0? No, because there's potential. So this measurement shows there is a power going into the switch, but not going out. There are 120 volts leading up to the switch and 0 volts going from the light switch of the light bulb. So it gives you guys points and stuff. I'm not going to answer these questions again, but it's a tool, and there's different things in there. So there's stuff for, like if I go in the catalog, I'll pull it back up. There's more than just the basics in there. I'll go back into the catalog, and I'll go to the HVAC catalog, and let's say installer year 2 apprentice. This is like 45 courses. I selected fundamentals. Core path fundamentals here. Then there's advanced heating diagnostics. There's stuff for, let's go back to the catalog. there's Nate training stuff in here. So scroll down, like there's HVAC basics, intro to heat pumps, compressor starting relays and capacitors, troubleshooting motors, gas furnace troubleshooting, heat pump residential troubleshooting. There's an assessment that you take to learn where your technician is at. You can use this assessment to actually do new hires. The Nate exams on here, like there's Nate training. There's trying to find the Nate training course, but it gives you all the different stuff that you would have to go to different places, train at different locations, spend all this time building training equipment, and it's all here. The system parts, what the components are. There's an AC motor lab on here. And this is all simulations with verbal and written instruction. So I'm still trying it out, and I'm trying to tell my guys I need them to be all bought into this, because this only works if your employees buy into it. And it's only going to be bought into by your employees if we buy into it, or if we buy into the training. Because I know that it sucks to have to pay to train someone and then they're going to leave. What's your options? You let them continue to do bad things and give your company a bad name? Or do you fix it and on the hopes that they're learning from you and advancing and you're doing the right thing and giving them raises and stuff, that they're going to stick around? And then you have a quality technician, the longevity of an employee. This is for us smaller companies that don't have the large resources of like some of these large companies that are overly sized. And they can just have a revolving door of technicians. I personally don't want a revolving door of technicians. I want to personally know every single one of my technicians. I want to know what their capabilities are. I want to know all my technicians are capable of the same thing. I know some guys are going to be a little bit better than others, but at the end of the day, it's only going to benefit your company or yourself by training your guys. And I don't mean by Nexstar training where you train them how to sell stuff, because I've seen the product of Nexstar training, and it's good and it's bad because it teaches them how to sell, but you have technicians that are just selling technicians, and they're just selling stuff, and they're just be like, oh, back capacitor, fan motor's not running back capacitor, and it might not have been a back capacitor, or they need a new fan motor, and it could have been just a back capacitor. But why is that capacitor failing? Why is that fan motor failing? Why did that compressor fail? How did you determine that compressor failed? Like I said, anybody can be a parts changer, but understanding how everything works and why we're doing something is the ultimate thing. It's the ultimate salute. Like, unless you understand how it works, like I have so many times where guys think that ECM motors have magical fairy dust and there's special computers and stuff inside of them. These ECM motors, whether they're constant airflow, constant torque, variable speed, they all operate off the similar principles. They have a module that is converting single-phase power into simulated three-phase DC. The motor itself, if you ever pull these modules off of these ECM motors, ohm out the motor. And guess what? Every single lead is the same resistance because it is a three-phase motor. And that's what we're going to, because it's more in a more efficient motor. But why did the ECM motor fail? What's the main cause of constant torque motors failing? Too much moisture in the air, because either the static's incorrect or the static's incorrect, causing that motor to have to constantly run harder and harder and harder, because a constant torque motor is going to ramp harder to run harder off that high static. And then you come in and you don't realize it, but when you fix the static problem, now you put a death sentence on that motor, period. That motor is going to fail at some point in time because it's so used to running here. And then when you fix the static, it's like, whoa, 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 I need to back off. And then it just dies out. Or you have too much airflow and you're ripping water off of a coil, or your condensate line's not done correctly and you're ripping moisture off the coil, and moisture's causing damage to the module. Nowadays, they're not really selling modules separate from the motors anymore, and they have to replace as a whole. But do you have to put an ECM motor back in? Can you give the customer an option? Most guys don't understand that you can put a PSC motor and replace an ECM motor. Is it efficient? No, but it might be a little bit cheaper for the customer. But you have to understand how to put a relay in and how to make that relay control that motor to operate properly. Because you want a certain speed in heating and you want a certain speed in cooling. You can do it, you just got to make sure you do it properly. You can do 2 different relays with one going to Y, one going to W, and you can do it that way. So that's why I said these trainings are teaching the fundamentals and they're getting into the advanced stuff a little bit, and you can kind of see where everybody needs to go. And no, Interplay did not sponsor this channel. Maybe they will. I actually have talked to one of the reps, and we're going back and forth, and there's probably going to be someone from Interplay Skill Mill who will come on here and we'll talk more about it and explain benefits of training in the fields. Because it's more than just HVAC on here. It's electrical, it's plumbing, it's all that stuff. I'm just saying we need to get better as an industry on training people. And I know I kind of went off on a tangent here, and it sounded like I was doing a sales pitch for Interplay, but that's not what I'm doing. What I'm doing is we need to better this industry and better ourselves and continue to let the same thing happen the way it's been happening for the past 10 years is not going to succeed our industry. It's only going to make our industry worse. Where everybody wants to sell equipment, replace the unit, not fix the unit. And I heard this thing the other day where it's like, oh, if the unit's over 10 years old and it needs $1,500 in repairs, try and sell them a new unit. I personally disagree with that. Give them the option. Say, hey, look, now if it's a compressor and the unit's 23 years old or 25 years old, sure. Probably time to replace that unit. But if it's like a fan motor, some of these ECM fan motors, like I had one yesterday that through final research that there was a way to replace it with an aftermarket motor, but I didn't know that because there was no definitive answer from Gentech on that. But that fan motor, the OEM fan motor, was $900 for a blower motor. $900. That's a $1,500 repair easily for a blower motor. Now, can we put a PSC motor in there? Sure. But as parts get more expensive, the repairs get more expensive, and it's going to get to a point to where it's like $1,500 and replacing a unit, not worth it all the time. If you're doing a fan motor, sure, everything else checks out, just do it. Now, I can understand if you had like a compressor that was showing signs that it's going out, or you had an outdoor fan motor and compressor showing signs of going out, cabinets rotting away, yeah, replace it. But we need to get better about fixing things and doing the right thing for the customer, and you can't do the right thing if you don't fully understand what you're working on. That's all I wanted to say. Kind of a long 43-minute way of saying it, but I want everyone to think about this and chime in if you feel differently. Tell me why. I had to do some convincing of people saying, hey, look, this is the way we should go because I can't reach everyone every meeting on certain things. But at least this way, I know I'm reaching everyone and I can see progress. And it's in their downtime. Yeah, it's costing us an upfront cost. And I'm not going to say how much we paid, but it wasn't like a couple $1,000s. It was thousands of dollars. But I personally feel in the long run, it'll make us look better as a company and make my technicians look better and they'll have a better understanding. Now, if they do leave the company, their seat is available for another technician. I can move it to another technischen that I hire. It's my seat. I paid for it. It's my program. So that is the benefit to it. But so if anybody has anything to say about it, appreciate it. And the person that told me about the video glitching out, I really do appreciate it. I'll tag you in this because I would have never known. I sometimes don't check the videos for a couple days after they upload. But when you said that, I looked at it right away and I was like, yep, he's right. It's glitching out. I tried to re-upload it. Still glitching out. But on my end, like from the actual video aspect, it was not glitching out. But every time I'd upload it, it would glitch out. I don't know if there was a compression problem when it was trying to upload or when it was compressing the file down. I don't know what happened. I'm sorry. I appreciate it. Thank you very much. And everybody, I hope you had a good Labor Day weekend. I know it's a little late for that, but keep on HVACing on. If you like this video or any of the other videos, hit that like button, subscribe, leave a comment, and as usual, happy HVACing.